Hi students, this is AJ sir. Let's study 9th standard ICSE Math chapter 25, Complementary Angles of Trigonometric Ratios. Also, to enroll for my online test series or online lectures, email me or message me on Instagram. Check the description for more information. Complementary angles means when the sum of two angles is 90 degrees. Supplementary would have meant when the sum is 180. Now, in trigonometry, we have certain relationships which we need to remember. Sine 90 minus theta is same as cos theta and vice versa. A similar relationship is seen between tan and cot and cosec and sec. So remember these pairs. Now, how to apply these in the sums? It's very easy. Question 1 can be cancelled because they are very easy sums. Let's start with question number 2.2. Sine square 35 degree minus cos square 55 degrees. So we will either convert sine into cos or cos into sine. I'm going to convert cos into sine. 55 can be written as 90 minus 35, isn't it? And we know that cos of 90 minus theta, that is any angle, is same as sine of theta, that is sine of 35. So we are converting cos square 55 degrees into sine square 35 degrees. So this step wasn't necessary, but I just wanted to show you how this transformation happened. Cos 55 is same as sine 35 because they are complementary, and sine and cos is a pair for complementary angles. And now sine squared 35 minus sine squared 35 is equal to 0, of course. So that's the final answer. Note that when I say cos 55 is same as sine 35, I can also say that cos squared 55 is sine squared 35. The next sum, the fourth sum, is this. So again, I will either convert tan into cot, or I will convert this cot into tan. So I'm going to write cot 37 as tan 53. This is the transformation I have brought about. Cot and tan are the complementary pairs, and 37, well, 90 minus 37 is 53. The reason why we are doing this is so that they can get cancelled. So that is only 1 will be left behind. 2 into 1, 2. If we would have converted this, it would be written as cot 37. Even then you could have cut cot and cot. Similarly here, cot 80 upon tan 10. So I have converted tan 10 as cot 80. So now even this will be cut and 1 is left behind. So the final answer is 2 minus 1, 1. Next, Roman number 6. Sine 77 upon cos 13 the whole squared plus cos 77 upon sine 13 the whole squared minus 2 cos 45 squared. Yeah, when they put a square here, it simply means it is cos 45 the whole squared. So in trigonometry, we can write the square out here as well. For example, this could have been written as cos square 77 upon sine square 13. Then that would have meant the same thing as the whole squared. That's just the way trigonometry ratios are written. So how do we solve this? So I'm going to convert this cos 13 as sine 77. Remember, 13 plus 77 is 90, right? So they are complementary. Similarly, this sine 13 can be converted into cos 77. You could have converted this cos 77 in numerator into sine 13 as well, but the effect is same. They will get cut. So it will become 1 squared plus 1 squared minus 2 into cos 45 Well, that value we need to know. So if you look at your textbook page 289 in chapter 23, there is a table and you need to remember all these values. There is a trick behind remembering it easily, which you will be taught in chapter 23. But we will just use this table as of now to find the value. So we wanted cos 45. So check. Cos 45 is 1 upon root 2. So that's the value we'll substitute here. And of course there is a square, so don't forget it. Squared. So root 2 into root 2 is 2. But the 2 and 2 gets cancelled, so 1 is left behind. So 1 plus 1, 2, 2 minus 1, 1. So the final answer is 1. Now let's go for question 3.2. It's a show that sum, proving sum. That means we'll have to solve it as LHS, RHS. Let's start with the LHS. Please don't copy the RHS in the very beginning, then it will be given wrong. So sine 42, sec 48, cos 42, cosec 48. So first of all, I'm going to convert the sec 48 as cosec 42. So the angles become same, 42 and 42. And it's pretty clear that 42, 48 are complementary. So this should be a hint for us to figure out what to solve ahead. Similarly here, cosec 48, I'm going to convert it to sec 42. Remember, sec and cosec are complementary pairs. So 48 and 42 are also complementary. Next, we know that cosec is nothing but the reciprocal of sine. And sec is a reciprocal of cos. So when you do the reciprocal, don't change this angle. Because this is a reciprocal relationship, not a complementary relationship. And the reason why we are doing this is because now we can cut sine 42, sine 42, cos 42, cos 42. 1 plus 1 is 2, and that is the RHS, hence proved. Next, 4.2. Now 4.2 is a very tricky sum. Cosec 48 plus cot 72. And they've said, rewrite it so that the angles are between 0 and 45. So we'll use complementary angles here. Instead of 68, we'll write 22, and instead of 72, we'll write 18. But if we are using the complementary angles, then what will be the corresponding replacement for cosec? Think about it. Yes, it's sec. And for cot, what was the pair? Complementary pair? It was tan. So the answer is sec 22 plus tan 18. That's the answer. Next. Mark 3.2 as IMP. And now 5.2 also is IMP. In triangle ABC, show that. So again LHS, RHS. But first of all, it's in a triangle. So we know that A plus B plus C is 180. Out of that, B plus C will be 180 minus A. Why did I take B plus C? Because in the question we have B plus C here. That's why. So we'll substitute the value of B plus C soon. See here. LHS was tan B plus C upon 2. But B plus C is what? 180 minus A. Substitute that value here. So this becomes tan 180 minus A upon 2. Now divide each of these terms by 2. So 180 upon 2 is 90 minus A upon 2. But tan 90 minus theta, which is any angle, is cot theta. That means this becomes equal to cot A upon 2, which is the RHS, hence proved. Next, 6.2. 3 cos 80 cosec 10 plus 2 sin 59 sec 31 is to be evaluated. That is solved. So how do we solve 6.2? Well, again I see complementary numbers here, 80, 10, 59, 31. So it's pretty obvious that we'll have to use complementary angles. First, I'm going to convert cosec into sine, the reciprocal relationship. The number won't change in reciprocation, okay? Similarly, sec will become cos. And now I will convert sine 10 as cos 80 and cos 31 as sine 59 so that I can cut them. So the final answer becomes 5. Another way to do this would be, we can convert cosec into sec 80 right here and sec 31 as cosec 31 first up. And then we can do the reciprocation. So sec 80 will become 1 upon cos 80. So it will be cut. And cosec 31 would become 1 upon sine 59. I'm sorry, this would be 59 here. So cosec 59 will become 1 upon sine 59. And that will be cut. So the final answer would be the same. So once you know all the formulae, there are so many ways you can solve it, which makes it so easy and interesting. Now 6.4 is IMP. So how do we solve this? Tan minus cot. So either you'll convert tan into cot or cot into tan. That should be obvious to you. I'm going to convert tan into cot into tan. We know that cot theta, this entire thing is theta, okay, an angle. Cot theta is tan 90 minus theta. Cot theta is tan 90 minus theta. And now open the brackets. 90 minus 35 is 55. And this becomes minus a. Now the terms are same, which we knew from beforehand. Cut it and this becomes 0. Another way to solve this would have been, this cot 35 plus a could have been written further as cot 90 minus 55 minus a in brackets. If you notice, this is same as cot 35 plus a if you open the brackets. And then we could have said cot 90 minus theta is tan theta, which would become the same thing. So that's just another method of getting the same answer. Now Roman number 6. So again, a very simple sum. Here we'll convert cot 33 as tan 57, tan 20 as cot 70, cut, but 2 is left here, so 2 minus 1. And here cos 45, if you remember the table, you have to go back to the table here, and cos 45 value we know it's 1 upon root 2 cut, and so 1 is left behind, and the final answer is 0. So we know the values of cot of any trigonometrical ratio for the angles 0, 30, 45, 60 and 90. We know all these values from the table. You should learn the table by heart. And then Roman number 8, again a very simple sum. Sine 20 is written as cos 70, sine 31 as cos 59, cut. Sine 30, if you refer to the table, it's 1 upon 2 and square is there. So don't forget the square. This is cut. This becomes 2. 2 minus 2 is 0. That's the final answer. Now mark the 7th sum as IMP. ABC is right angled at B. That means B is 90. That means angle A plus C will also be 90. Keep that in mind. That A plus B plus C was 180. Out of that B is 90. So A plus C is 90. So either you can take A as 90 minus C, or you can take C as 90 minus A. Either of them has to be substituted in the sum. So we start with the question. I am going to replace A's. This is replaced. This is replaced. Sine B. B was 90. And you know sine 90 is how much from the table? It's 1. Check it out. Go check it. So sec 90 minus theta is cosec theta. So this becomes cosec C. And this tan 90 minus C becomes cot C. So the good news is that now we have only angle C in the numerator. Now what? Now the reciprocal relationships. Cosec is actually 1 upon sine. 1 upon sine C. So cut. Similarly, cot is 1 upon tan. Cut. So you should remember all these reciprocal relationships as well as the complementary relationships and the table. If you remember all these things, then you can solve any sum from anywhere. So the final answer is 1 minus 1 upon 1, that is 0. Finally, 8.2. They have given this equation and we have to solve this to get the value of a, the unknown variable. Okay. First of all, I know that cos 90 minus a will become sin a. Sin a, yeah, complementary relationship. Sec 77, let me write it as 1 upon cos 77, the reciprocal relationship. And cos 77, by the way, is sin 13, the complementary relationship. Sin 13 goes up. So now I know that sin a is equal to sin 13. That means a is equal to 13. No, it's not that we can cut sin and sin, although it looks like that. It's just comparing that sin of a is sin of 13. That means a has to be 13. Another way would be, instead of sec, you write sec 77, you write cosec 13, complementary relationship. Cosec 13 becomes 1 upon sin 13, so you reach this step anyway, and the rest of the method remains the same.